Welcome to the concepts in electrical and electronics engineering. In the earlier lecture, we have seen what is a valence electron, what is an energy band, and what is resistivity of a material, classification of materials based on the valence electrons, energy band, resistivity. In this video, you will be able to know what is a charge, what is electric potential, what is a potential difference, what is electromotive force, and voltage and current. Let us see charge. So to understand what is a charge, let us consider two glass rods which are rubbed to a silk cloth. When they are rubbed to a silk cloth, it acquires a positive charges, and silk cloth acquires the negative charges. There is no like acquiring a positive and negative charges. It is like transferring the electrons and protons from one substance to the another substance. So therefore, two glass rods which are obtained the positively charged, when they brought together, they repel with each other. Suppose let us consider the another case, a plastic rod rubbed with a fur. What happens when the plastic rod rubbed with a fur? It acquires a negatively charged. So that means the fur acquire a positive charges. So this plastic rod, when brought in conjunction with this glass rod, they attract with each other because they will attract because the positive and negative charges attract with each other. So we find that a glass rod rubbed with a silk acquire something different from that of plastic rod rubbed with fur. It is that something, it is a charge which is being acquired. So when the glass rods are rubbed with the silk cloth, they are getting a positively charged, and while plastic rod rubbed with the fur, they are getting a negative charges. So let us see, before going to the potential difference, what is atom. So we know that atom consists of electron, proton and neutrons. Electrons are negatively charged and protons are positively charged. Proton charge is denoted by plus E and electron charge is denoted as minus E, where E is equal to 1.602 into 10 power minus 19 coulombs. So electron as well as the proton is having the same number of coulombs but with positive and negative signs. So atom are normally neutral. So when it is said to be a neutral, means they have exact number of the protons and electrons. So then what is the charge balance? When there are equal number of protons and electrons are there, the net charge is said to be 0. Suppose an atom which is having the more number of protons and less number of electrons means charge imbalance occur, and when more number of protons means the atom is said to be a positively charged material. Similarly, the vice versa. So now the question, which type of charge is easy to remove from an atom? The answer is electron but not the proton, because proton is somewhere in the nucleus, electron which is rotating around the nucleus and particular orbits, so it can be easily removed. So in fact it is removing the proton is also very difficult, and it is a special case considered in radioactive elements. So from this discussion we are going to consider only the electrons which can be removed. So suppose if you remove an electron, what is the net charge on the atom now? So removing the electron means the positive charge will be acquired. So here the question comes, if we cannot able to remove a proton, then how can we make the a body it to be a negatively charged body. So the answer is, if we add the more number of electrons to that body, so therefore the atom is said to be a negatively charged. So the conclusion is, the excess or defect of electrons in an atom is called charge. Suppose there are more number of electrons in a particular atom, it is said to be negatively charged. If there are more number of protons in a particular atom, it is said to be a positively charged. So unit of coulomb, unit of charge is nothing but a coulomb. It is denoted by Q. So 1 coulomb of charge is equal to 6.28 into 10 power 18 electrons. So based upon the above discussion, how many charges are there? One is a negative charge, one is a positive charge. So a negative charge means, as discussed, the excess number of electrons. Positive charge means, instead of telling the more number of protons, we can tell it as a defect of electrons. So capacity of charged. Now see the electric potential. Capacity of a charged body to do a work. So how much of energy is required to bring the positive charge to that particular point? It is said to be an electric potential. Unit of electric potential is a volt. So 1 volt is equal to work done in bringing the a positive charge from infinite distance to that particular point against the electric field, so is nothing but a volt. So you can define it as electric potential, or in 1 joule by 1 coulomb. So as defined, electric potential at a point in a particular electric field is the work done in bringing a unit positive charge from infinity to that particular point against electric field. You can see the electric field shown here, and a point at which the electric potential is to be determined. Also, the work done in bringing this unit positive charge from infinity distance to this particular point. So then what is potential difference? The difference in the electric potentials of two charged bodies. Say suppose a uncharged body is having some N and another charge of a body M. So N minus M gives the potential difference. So unit of the potential difference is volt. Say suppose A is a body having a 7 plus 7 volts. So B is a body having the plus 3 volt. So body A at a potential of plus 7 volt and body B at a potential of plus 3 volt. So what is the potential difference between these two charged bodies is 7 minus 3, which is equal to 4. So if these two bodies are connected through a wire, what happens? Electron flow from higher potential to the lower potential. Means from, you can see the electron flow from higher potential to the lower potential. See, higher potential means plus 3 volts, because plus 3 volt is nothing but, plus 3 volt means minus 7 electrons are there. Here on the left hand side, plus 7 volt means plus 3 electrons are there. That means A is a body having a less number of electrons, and right hand side B is the body having a more number of electrons. So electron flow is always from higher potential to the lower potential as observed. So example, consider the two reservoirs A and B containing water at different levels. So A is a reservoir and B is reservoir connected through a pipe here. So A is obviously having a large potential compared to B. So higher potential means it tries to push the water towards the lower potential B. So when until the two reservoirs become equal, this is being done. So electromotive force, EMF, is the force which drives or tends to drive the electrons in a circuit. So these electron movement, something is required to move these electrons from one end to the another end, that is nothing but electromotive force, and unit of the EMF is a volt. You can observe the random motion of the free electrons without applying any force, maybe some valence electrons. The valence electrons are the electrons which can move with only a little application of the electric potential. So electromotive force, the conductor is connected to a battery here. In this case, EMF maintains a potential difference, while the potential difference causes the electrons to flow. You can observe the battery on the left hand side is having a positive charge, and on the right hand side it is a negative, plus and minus here. So what is the electron flow? So you can observe the electron flow here, the direction of the electrons you are observing. It is from right hand to the left hand, because here negative charges are moving from higher potential to the lower potential, because a positive terminal means high number of protons and low number of electrons. So on the right hand side, negative means more number of electrons and less number of protons. So therefore the electrons flow from right to the left. So but actual current will flow from a positive terminal to the negative terminal. You can see here a bulb glows with the help of the battery, where the direction of the flow of current from positive terminal to the negative terminal. So then what is voltage? It is a synonym to EMF and potential difference. So hence the unit of voltage is also volt. So it's a voltage is nothing but the amount of energy required to move the electrons from one part to another part. Let us see what is a current. Flow of electrons is nothing but the current. Charge, that means flow of electrons is nothing but it is having some charges. So these charges, how they are flowing per second rate, is nothing but the current. It is denoted by the I. A unit is ampere. So current I is equal to charge by time as per the definition. So I is equal to Q by T. We generally Q units is coulomb and time is in seconds. So 1 ampere you can define it as a 1 coulomb by 1 second. So 1 ampere of current is said to flow through a wire if it at any section 1 coulomb of charge flow in 1 second. As an example, if 10 amperes of current is flowing through a wire, it means that 10 coulombs of charge are flowing per second. So you can consider here the electron flow is from right to the left, whereas this is the flow of electrons. See the direction of the conventional current. The direction of conventional current is from positive to negative, whereas the direction of flow of electrons is from negative to positive. So concept of current direction. Conventional current, the assumed and traditionally followed direction of current is from positive to negative. The direction of actual flow of electrons is from negative to positive. So in this class we have learned about what is a charge, what is electric potential, what is potential difference, what is electromotive force, what is a voltage, and what is current. So let us have a small quiz. What is the unit of charge? As discussed, unit of charge is coulomb. The current is measured in obviously the amperes. What is the unit of EMF? Is volts. Thank you for watching the video.